this video, we're going to talk about determining whether or not in your data set you have any outliers. So, if you have any outliers in your data set, they can offset your statistics, and they can, but they should be removed. Okay. So typically, when you do an outlier detection test, you must do it only one time. You can't keep changing your data set after you determine your initial set of outliers. Okay. So in order to identify outliers, we use something called Chauvinist Criteria, which is based off of the z-score. So what it basically says, if 1 minus 2 times the probability of your z-score, okay, or you can think about this as being the area inside your your Gaussian distribution, like the inside of it, not like the outlier extremes. Okay, if that number is less than 1 over 2n, that data point is an outlier and can be removed. Okay, so we'll do an example of how you would apply the Shownotic criteria using Excel. Okay, so the first thing we can do, all right, is we have our data set here. Okay, so notice that our data set has 10 points. Okay, all right. So the first thing we would do is we would calculate the mean of our data. Okay, so the mean, we just take the mean of all our data points. All right. Alright, and then we would find the standard deviation as well. Okay, so nice and easy, nothing too crazy there. Okay, based off of the mean and standard deviation, alright, we can calculate the. Let me actually change this to standard deviation S. That's the proper one. Oh. Maybe not. Sorry, give me a second here. Alright, and what you'll see here is we'll get our z values, right, for all of our different z's. Okay, so alright, nothing too crazy. We'll just go down and calculate all of our z values. Okay, alright, now once we do have our z values, we can use the norms distribution function. Alright, and we're going to find the lower bound and the upper bound based off of our z-score. So to find the lower bound, what we're going to do is we're going to take the absolute value of our z value, and we're going to find the negative value of it. Okay, then we're going to do the same thing with the absolute value of it. Alright, of just the positive value of it. That will give us our lower bound and our upper bound. Okay, alright, just taking the z-score, using the norms distribution function, and plugging in the negative value for the lower bound, of our probability, and for the upper bound of our probability, we're going to use the positive value. Once we do that, we have the total probability, which can take the difference between the two. Alright, and then we can then find 1 minus the total probability value, which we'll use for our Chauvinist criteria. Okay, so we're just going to take 1 minus column H. Okay, so we'll do that for all of our data. Alright, and then we'll come up with our 1 over 2n value. So in our case, we have 10 data points, so 1 over 2n would be equal to 0.05. Alright, and that'll be the same for all of them. Alright, then we can just do a quick test. Basically, if column I is less than column J, we have an outlier. Okay, so the only time this happens in our data set, alright, is on point number 9. Okay, and at point number 9, you'll notice is that we have our outlier, which makes some sense because the reading we were taking was 18. Alright, and 18 is much smaller. It's around 9 psi smaller than the mean, and a few data points beyond our standard deviation. Okay, so that makes sense why it is an outlier. Okay, so the Chauvinist criteria is a nice way to identify outliers, and if you can automate it in Excel, for a larger amount of data points, you can identify those outliers really quick, and then you could recalculate your mean and your standard deviation based off of the new data set. So basically what you could do is you could copy your data set. Alright, you would then eliminate this outlier, and then you would calculate your mean. Okay, so you can calculate your mean. right, and then your standard deviation. Sorry. Alright. So what you'll notice is that once you remove the outlier, our mean went up from 26.9 to 27.9, and our standard deviation decreased a ton. It went down to only a standard deviation of 1.9. So identifying outliers and eliminating them can really affect your statistics. All right. So